So my name is Cristian Iaconi. I am an architect from Romania, and I will present my master thesis work, the topic designing buildings for 3D concrete printing. I will start with a brief overview about the topic about the automation and construction. And as you can see in the image, there are some similarities between what was predicted and what is developing right now. On the left image, you see an illustration from more than 100 years ago, where people predicted that an architect will push some buttons and the rest of the works will be automated. And on the right, you see contour crafting. That is a type of 3D concrete printing that is developing right now. So the motivation behind this topic is my professional development as an architect. I want to become more ready and confident in designing buildings for this kind of technology. So what's the problem? The problem is the knowledge between what we can design and what we can build with 3D concrete printing. And the research objective is to close this knowledge gap. The thesis structure is divided in two sections. First one is theoretical knowledge, and the second one is practical application, where I start to design a building from scratch and adapting it to the 3D printing process. 3D concrete printing starts in 1995 with its theoretization by Professor Kośniewicz. And later in 2004, he proposed a system for 3D concrete printing, but the real application starts in 2014 by a Chinese company, when they start to printing buildings, and later 1 year they even assembled a 5-story building, as you can see in the image. After that, a lot of 3D printed buildings appear, mostly in Europe and North America, but not just the buildings, also infrastructure as bridges. And in this year, the largest 3D printed building was made in Germany. As you can see, this type of technology is evolving rapidly, and there are like 3 main elements that make this technology possible. First one is the material and its phases, like production phases, pumping phases, and printing phases. And for the printing phases, we need the next most important element, that is the motion system. There are many types of motion systems, but the most popular ones are gantry system that moves in 3 directions. It's huge, and it's mostly used for outdoors printing. And the second one, it's an arm robot. It's more flexible, more expensive. It can be adapted to be mobile, or it can be fixed. As you can see in the image, is a type of hybrid, and it's mostly used inside, for printing inside. But in order to print, this motion system needs a digital model. And the digital model has its own three development phases, as you see in the image. It's a global design, material distribution, and printing path. Usually these 3 steps are made by different professionals, but the architect is involved in all of them, like to close the gap between them. For 3D printing, there are like 2 main approaches. As you see in the image, is in situ printing, where you printing on site, and there is pre-printing. It's more like a kind of prefabrication. So in situ printing is mostly used for printing the walls of the buildings, and pre-printing is mostly used to print elements that can be a part of the building or a part of infrastructure. Or you can combine this type of printing approaches. And to explore more, I did some case study analysis. And for first one, it's a residential building from Germany. It's made by in situ printing, mostly because in Germany we need to put thermal insulation and the exterior printed layer doesn't need to be connected with the interior layers. And then the next image, we see a project from Dubai where they didn't use thermal insulation and was easy to build by pre-printing from multiple parts. So with these case studies tell us that the location has a huge impact on the printing approaches, but we also combine them. And for that, I analyzed a project, a farmhouse from China, where they combine these printing approaches. For example, they prefabricated the foundation after they printed in place the walls. And as you can see, the roof was pre-printed near the site and after installed. The practical part starts with design a building from scratch. As you can see in the image, I used Autodesk Revit for that. I divided the process in two main phases by creating two phases directly in Revit. First one is the global design, where I took in account only like the overall dimensions or overall configurations of the building. But also on this phase, I took in account the printing bed, printing supports, and I avoided overhanging elements and also sharp angles of the walls. And in the next phase, design optimization, I made the design more detailed by highlighting the printing elements from the rest of the building and also separate printing elements in the construction phases. As you can see in the design optimization, starting with the foundation, usually for a 3D concrete printing, the foundation is made by traditional construction methods, but we can integrate 3D printing. And I used the 3D printing to create like a wall used for the formwork of the foundation. And the rest of the process it's done in traditional way. And the second printing phase is the walls, is the most important one. And for that, I created multiple types of walls that contains also multiple layers. For example, the envelope wall, you can see on the left, it's created by multiple printing layers of walls that was created as at a separated wall. We have A, it's a decoration wall. We have E, it's like thermal insulation, and with red, it's structural printed layers of the walls. And also in the image on the right below, we see how the walls also was separated in the printing phases. The upper part, it's a separate printing phases because it will be printed after we install the printing supports on the windows. Next one is the slabs. The slabs we cannot print on the place, so there was designed to be multiple small printing panels. This work should be more done with a structural engineer, so I didn't explore very deep this part. And also for 3D printing building, we can print some elements that can be part of the building. For example, the stairs that are made from stair supports. The stair supports were designed to be as a walls, so they will be printed in the same time of the walls and exported with the walls. And we have stairs that will be printed in horizontal direction, and after they will be rotated and installed. I will not continue with the next level of the building because it's a repetitive process, and I will go to the next process stage. So this is the exporting. For exporting process from Revit, it's very easy. We just creating 3D view for each printing phase. In each printing phase, we are hiding the elements we don't want to print, and we keep only the one we want to print. And for printing, for example, just one printing phase, we going to that view, and we're going to export CAD format and STL format. STL format, it's used mostly for 3D printing for for every kind of 3D printing. It doesn't matter, it's a small scale or a big scale. After exporting in STL format, we going to the slicing. Every motion system comes with their motion system, native motion slicing program, but we also have an open source, like in the image below, where I uploaded stairs and sliced them. From an architect point of view, the slicing part is done just to check the model if we will not have the problems. For the small scale model, it's a bit different because of the scale effect. I exported in STL format not only the 3D concrete parts, but also I added some other layers, the model to be strong. And the slicing programs are more available. So I was used a real slicing software. And after that, as a digital results, I got a BIM model and STL models. The BIM model contains all the elements of a digital model, but STL model contains only the printable parts of the building, as you can see the image. And as a physical result, we got a small scale printed model that was printed in multiple parts, and we can connect them as a Lego. And as conclusion, 3D concrete printing technology has more impact on the construction process than on design. And all 3D printing technologies have a similar principles of operations. And all the process I showed in this master thesis can be done with conventional BIM software tools used by architects. So we don't need another kind of softwares if you don't want to go deep in doing something more original. As a future work, to improve the model quality, we need to do some real scale printing attempts. For that, we need a real scale motion system that printing with the concrete. Also, if you want to do some printed wall patterns, something original, it's not enough to use a digital model. For that, we need to manipulate manually the printing path. It cannot be done with automated slicing software. And as a limitation, the impossibility of printing overhanging elements still limits the design option of the architects. So that's all for my master thesis. Thank you for the attention. And in the end, you can see a render of the printing walls phases. Thank you.